In the last videos, we started looking at the measure of center. Now we're going to dive a little deeper into the measures of center. So before we just looked at, hey, what is the largest peak in our data? And, that was our mode on the histogram and the most frequent value. But there's different measures of center, and depending on what kind of distribution we have, one's going to be used more frequently than another. So the three most common measures of center we have is the mean, the median, and mode, where mean and median are most useful usually for numeric data, and the mode is often used for categorical data because it would be the most frequent value, and it's also used on histograms to show us the peak. So again, this is often used for categorical data or histograms. And then we're going to see for the mean and the median, there are going to be different rules on when we would rather calculate the mean versus median, but our numeric data allows us to calculate both. And then we're also introducing a mid-range, which is kind of a fast, easy measure of center to calculate. It's not really that useful. It's not commonly used, but we just introduce it just to show you because it's a very easy definition. And it also shows you that there's many different measures of center. So again, we talk about a typical or an average outcome, and depending on the shape of the distribution, we may want to use a typical value as the mean, or we may want to use the median instead. So all of you guys have seen how to calculate the average before, and this is basically the balance point over here on a scale. Right? We have this summation notation, which just means add up all the values from the first to the last and then divide it by the number of values you have. So you've seen this many times before, you've calculated this many times. You may not have seen the summation notation, but again, it just means add up all the values you have from the lowest to the highest and then divide by the number of values you have. So if we're doing an example over here, to find the mean of our data set of 10, 11, 15, 19, 20, and 80, we simply add up these values and then divide by how many values we have. So we're going to divide it by 6. Our numerator adds up to 155. We're going to divide it by 6, and we end up with about 25.8. So this is our first average, which is our arithmetic mean, probably the most commonly used average that we've seen in algebra. Our second measure of center is our median. So again, these measures of centers, this is also an average, right? It's also a midpoint of our data. This time, we're simply going to look for that middle point. So we're simply going to go from the lowest to the highest score, and we're going to find out what is that value that's right in the middle. The one thing we have over here, we have the position formula, which tells us, take the number of items you have, add one extra to it, divide by 2, and that will tell you the location of your midpoint. On the other hand, you can order your values from lowest to highest, like we have over here, 10, 11, 15, 19, and 20. You can simply start crossing out from left to right until you either have one value or two values in the middle. If you have one value in the middle, that is your median. Again, just to show you the position of our median, over here we had 5 values to begin with. We added 1 to it. We're going to divide by 2. That's 6 over 2, or our third value. So we have 1, 2, 3. Our third value is 15. So that just tells us the position of it. If we have, on the other hand, an even number of values, again, when we start crossing out, we end up with 2 values in the middle, and our median is actually located right in the middle. So we can add 15 plus 19 divide by 2. It's located right in between 15 and 19, so 17 would be our median. And just to look at our position formula, with 6 plus 1 over 2, this would be equal to 3.5, which tells you it's located between the third and the fourth. So you're going to take the third value, you're going to take the fourth value, and you're going to average the two. So fairly straightforward. Most of you guys have probably seen the median before. Again, there's disadvantages and advantages for each one of those, and we're going to go more into when we would use the mean, when we would use the median, what kind of data we would use the mean, what kind of data would we use the median. And so this is why I want you to really think about, like, hey, if I look for how much you spend on a haircut, what do you think that distribution is going to look like? What's that shape of the distribution going to look like? What if I'm looking at your heights, right? What is that shape going to look like, and so on? Because depending on the shape, you're going to use either the mean or the median. And just to kind of finish up looking at those different measures of center, we have the mode, which is the most commonly used value. Again, that would be our peak on the histogram. Or, you know, if we have a frequency distribution for like categorical data, like if we're looking at, hey, which one is the most common eye color? Maybe we have, 20 students with brown eyes. We have, 2 students with blue eyes, maybe 5 with hazel eyes, or, and 5 with green eyes. And then we can look at, oh, brown is going to be our most frequent value, and that's going to be our mode. So generally, you're simply going to look through your data set. You're going to look at what is the most common value. Let's say we have a data set that's 1, 3, 3, 3, a couple of 5s, 8, 10. Our mode would be 3 because that is the most common value. Last one over here is the mid-range, which is the average between the minimum and the maximum. So the way we calculate is take our minimum, add to it the maximum, divide by 2. Again, if we look at the same data set as above, we would have 1 plus 10 over 2, which is 11 over 2, or 5.5. And you'll see, depending on the measure of center, you're going to get very different answers for each one of those. So when do we use what measure of center, right? Over here, when we have a symmetric distribution that is unimodal and mound-shaped over here, so an approximately symmetric or approximately normal distribution, our mean and our median are the same, and usually that distribution is described by using a mean. If, on the other hand, we have a skewed distribution, our mean is very much affected by the skew, where the median is not affected by it, and therefore we want to use the median because it gives us a better picture of the average value. You can think of like housing prices for San Diego, right? A lot of the houses here are, $500,000, $600,000, $700,000 range, but then we have some houses in La Jolla that are $2 million, $3 million, $10 million, $20 million, and you don't want to have that very large value skew your average, right? If we're calculating the mean, those large values are going to pull the mean into the direction of the tail, and the median is going to be a much better average value of a house in San Diego. So again, that's the idea why we want to use the median for skewed distribution or not symmetric distribution. We're going to use the mean for our symmetric distribution. We call the median a resistant measure of center because it is not affected by those outliers. Where the mean is not resistant measure to outliers. So this is really, really important, and oftentimes I will ask you this question when, look at this graph, what would be the best measure of center? Again, for our symmetric, unimodal bell-shaped distribution, we want to use the mean, and for our skewed or non-symmetric distribution, we want to use the median again. because the median is going to not be affected by the outliers, where the mean is very sensitive to outliers.